Good evening, my name is Celeste Stanwood, and today I will be covering Canyon Woodcraft's Enterprise Network. Here are the topics that we will be covering in this presentation. With the initial growth of Canyon Woodcraft in both scale and sophistication, with their main office housing more than 300 employees and the need for a new location to be created in Flagstaff, Arizona, the following changes were made to accommodate. For FLG RTR01, the hostname was set and IP domain lookup was disabled to prevent unnecessary DNS queries. The internal interface was enabled with a subinterface for VLAN 40, serving as the default gateway, while the external interface was set to obtain an IP dynamically via DHCP, with a default route forwarding traffic to the ISP. On FLG SW12 and FLG SW11's hostnames were set, IP domain lookup was disabled, and VLAN 40 was created with a management IP of 10.4.0.12/24 for FLG SW12 and 10.4.0.11/24 for FLG SW11. The default gateway was set to 10.4.0.1. Access ports were assigned to VLAN 40 with DTP disabled, and trunk connections were restricted to VLAN 40 for proper segmentation. Additionally, a labeled trunk connection was added between FLG SW12 and FLG SW11, ensuring controlled VLAN traffic. Configuring the initial network, what that did, the benefits to Canyon Woodcraft's enterprise network. VLAN segmentation improved performance by reducing broadcast domains, enhancing security through isolation, and simplifying troubleshooting and management. Router configuration provided centralized control over routing and internet access, enabling efficient VLAN communication and ensuring internet access for internal users. Switch configuration enhanced scalability for adding devices and switches, enabling efficient inter-switch communication. Default gateway and IP configuration supported remote management, monitoring, and centralized network administration. Shifting into spanning tree protocol, SDP, and Ether channel configuration at the corporate office, with the corporate office in Phoenix, Arizona, having redundant network through its switching architecture to address potential concerns regarding loops and Ether channel between the core switches, the following was implemented. But first, what is SDP, spanning tree protocol? It prevents loops by creating a loop-free network topology, and it includes root bridge election, determining the central reference for path calculations. Path cost calculation selects the lowest path cost path to the root bridge. Port roles assignment prevents loops, and loop prevention ensures a single active path by blocking redundant links. And then Ether channel bundles links into a single logical connection for increased bandwidth and redundancy. Increased bandwidth improves data transfer rates and handles more traffic. Redundancy ensures network availability by keeping remaining links active. If one fails, load balancing distributes traffic efficiently across the links to prevent bottlenecks. Simplified management treats multiple links as one, easing configuration and troubleshooting. So what implementations were made to fix this? RSTP configuration for faster convergence and loop prevention, bridge priority on PHX Core 1 for VLANs 10, 12, 14, 16, and 240, ensuring it is the root bridge. BPDU guard and port flash enabled on access ports to prevent STP issues. Ether channel between PHX Core 1 and PHX Core 2 using GI 111 through 4 for redundancy and increased bandwidth. Trunk configuration on port channel 1 allowing VLANs 10, 12, 14, 16, and 240 with DTP disabled and a 2-core description. Redundancy and high availability with dual core switches, ensuring failover to PHX Core 02, performance and load balancing through LACP, Ether channel, and VLAN trunking, security enhancements with BPDU guard, and portfast preventing STP disruptions, simplified management with clear interface descriptions and standardized configurations, reliability and fast recovery with RSTP reducing downtime, and safe configurations preventing loss. And here's the network diagram after the implementations were made to address the needs and concerns as previously discussed. And if you direct your attention to the sides, you can see the spanning tree summaries and interface statuses on the devices. Moving to OSPF configuration between Phoenix, Austin, and Denver branches. With the additional growth to the company and Canyon Woodcraft expanding into Colorado and Texas with the new locations in Denver and Austin, the company needed the branch offices in Colorado and Texas to connect to corporate through MLPS for all 3 sites. And to do so, the implementation of OSPF was addressed to run on the core switches and routers at corporate and the routers at the 2 new locations. Additionally, the 2 new locations were to be set up to share internet connections with the Phoenix corporate office. So what is OSPF? Open Shortest Path First is a dynamic routing protocol used in IP networks. It is an interior gateway protocol, IGP, designed to distribute routing information within a single autonomous system. OSPF benefits enterprise networks by providing scalability through hierarchical design, interoperability across different vendors, and efficient routing with its link state algorithm for optimal path selection. It enhances load balancing with equal cost multiple path ECMP routing and ensures robustness through fast convergence and adaptability to network changes, minimizing downtime and improving stability. So what changes were made to implement this? PHX Core 1 acts as the central router, configuring OSPF in Area 0 for communication with core and branch routers. PX Core 2 mirrors in configuration, providing redundancy and failover. PHX RTR01 connects Phoenix's internal network to the core while keeping Area 1 separate from Area 0. AUS RTR01 and DEN RTR01 serve as branch office routers in Austin and Denver, respectively, configuring MPLS interfaces for WAN, VLANs for internal networks, and OSPF to connect to PHX Core 01. Together, these configurations ensure efficient routing, redundancy, and seamless communication between the Phoenix network and its branch offices. And on the screen, you'll find a network topology diagram of Canyon Woodcraft's extended network with the new locations, and to the sides, the OSPF IP routes for each router, respectively. Moving to network security, ACL's port security, DHCP snooping. To address the company's concerns with uncontrolled devices accessing the internal networks and employee use of time at work accessing social media, the following implementations and security controls were created. First, what are ACL's access control links? Lists enhance network security by filtering traffic based on IP address protocols and ports, preventing unauthorized access. Port security restricts switch port access based on MAC address, preventing unauthorized devices from connecting. And DHCP snooping acts as a firewall between untrusted hosts and DHCP servers, preventing rogue DHCP servers from distributing unauthorized IP addresses. And those implementations on the network, PHX Core 01 and PHX Core 02 implemented the GW Internet-only ACL to restrict guest Wi-Fi from accessing internal corporate networks while allowing other traffic. AUS RTR01, DEN RTR01, and FLG RTR01 use the Internet Filter ACL to block HTTP and HTTPS traffic to Socialgram, ensuring compliance with network policies. And these configurations benefited Canyon Woodcraft by improving network segmentation and security, ensuring guests can only access the internet while keeping internal systems protected. Traffic filtering and policy enforcement prevent social media distractions, enhancing productivity. And on the screen is a diagram in Cisco Packet Tracer of Canyon Woodcraft's network topology following the ACL's implementation, and on the sides, the results of each of the devices' access lists now. DHCP snooping and the implementations. Support security is enforced on FA 0/1 through 24 by restricting access with sticky MAC addresses, allowing a maximum of 2 MACs per port, and setting violation mode to shut down. The purposes and benefits of this were these measures enhance network security by restricting unauthorized devices, mitigating DHCP attacks, and reducing potential attack surfaces by isolating unused ports and ensuring controlled access. The network remains stable, reliable, and compliant, safeguarding Canyon Woodcraft's enterprise infrastructure. And on the screen is a diagram of the network following the implementations, and again on the sides shows the DHCP snooping changes, allowed IPs, port security, and VLANs. Moving to NAT configuration in the corporate office and Flagstaff branch to address the issues regarding a corporate office router being removed from NAT configuration and Flagstaff NAT configuration also being removed. The following was addressed and implemented. In addition, Canyon Woodcraft CRM, ProfitForce.com, ERP, Connect.com, and productivity apps, Megasoft.com, were restored and configured to remain connected to internet services. NAT, what is it? Network address translation. NAT modifies network address information in IP headers to map one IP space to another as packets traverse a routing device. The purpose and benefits of this is NAT helps conserve IP addresses by allowing multiple devices to share a single public IP. addressing IPv4 limitations. It enhances security by hiding internal IPs from external networks, reduces exposure to attacks. Additionally, NAT simplifies network management by enabling internal IP changes without disrupting external communication, making it useful when switching ISPs or restructuring networks. What were the changes implemented for this? So at PHX RTR01 and FLGR TR01 NAT configuration, both routers implement an extended ACL NAT resources to deny VPN traffic between Phoenix and Flagstaff while permitting NAT for specified subnets. NAT overload PAT is configured with inside and outside interfaces, ensuring efficient IP address usage and secure data flow. The purpose and benefits of this is NAT overflow allows multiple internal hosts to share a single public IP, optimizing IP address allocations, including VPN traffic from NAT, ensures secure direct site-to-site communication while maintaining IP integrity. And this enhances network security, reliability, and performance by preventing external threats, reducing IP conflicts, and simplifying troubleshooting. And to the right, there's a table that depicts the key differences between the two routers that were configured to do this. Next, we have the diagram depicting the network following the changes made due to the concerns by the company, and to the right of the network diagram are the new IP access lists and NAT statistics for those devices. Moving on to DHCP services on the routers at Austin, Denver, and Flagstaff branches to address Canyon Woodcraft's goal of centralizing server infrastructure while maintaining reliable network services. We configured DHCP services on the routers at Flagstaff, Denver, and Austin to ensure local IP address assignment and network connectivity. Dynamic host configuration protocol, DHCP. What is it? It automates the assignment of IP addresses and network configuration parameters, enabling seamless device communication within IP networks by eliminating manual IP configuration. DHCP reduces errors and simplifies network management, making it particularly beneficial for larger networks such as Canyon Woodcraft. DHCP optimizes network efficiency by dynamically allocating and reusing IP addresses, preventing conflicts, and ensuring optimal resource utilization. And the protocol also offers flexibility and scalability by supporting both static and dynamic address allocation, allowing networks to expand efficiently while maintaining effective IP management. Changes made to Canyon Woodcraft DHCP services were configured on AUS RTR01, DEN RTR01, and FLG RTR01, each managing a different subnet and VLAN for IP allocation. To avoid conflicts, the first 50 IPs were reserved for critical infrastructure like routers and switches, while the last 54 were set aside for other static devices. Each VLAN has a dedicated DHCP pool defining the network, subnet mask, default gateway, and DNS server, along with the domain name suffix canyon.local. This setup ensured efficient IP management and seamless network connectivity across all locations. And here is the network topology for Canyon Woodcraft showing the changes made, and on the right outlines the changes made for DHCP to those specific devices. Lastly, advantages and disadvantages of managing network devices through Telnet, SSH, and SNMP. So what is Telnet? Telnet is a simple to use and widely compatible with various network devices, making it a convenient tool for network administrators. However, it has significant security vulnerabilities as it transmits data in plain text without encryption, making it prone to eavesdropping and attacks. Additionally, it lacks advanced functionalities such as file transfers and port forwarding. SSH Secure Shell enhances security with strong encryption and supports public key authentication, reducing reliance on passwords. It also offers advanced features like secure file transfer, SFTP, port forwarding, and tunneling. However, SSH can be more complex to set up and may introduce latency due to encryption and decryption processes, potentially affecting performance in high traffic environments. Lastly, Simple Network Management Protocol, SNMP. SNMP enables centralized and real-time monitoring of network devices, allowing administrators to proactively manage network performance. It is highly scalable, making it suitable for networks of all different sizes. However, older versions SNMP v1 and v2 lack stronger authentication and encryption, posing security risks. Additionally, configuring SNMP can be complex due to the need for management information bases and continuous polling of devices may impact network performance. Here are the topics that were covered in this presentation. And here are the sources for the resources and information utilized in this presentation. Again, my name is Celeste Stanwood, and this was my presentation on Canyon Woodcraft's Enterprise Network.